All right, Pythagorean identities. You use these in trig equations, but they're really something we use in trig proofs as well. So these can go either place. Remember, for all of our trig identities, for all of our Pythagorean identities, we're going to start with sine squared plus cosine squared equals 1. Or you can call it cosine squared plus sine squared equals 1. Either way, doesn't that matter. We're going to use this identity 3 times to solve for our different pieces here. So I'm going to go ahead and see if I can copy and paste that. Twice, and we'll just have it to work with. So for part A, we're solving for secant squared. And in order to use our identity here and get secant squared, we need cosine squared on the bottom. So I'm going to divide everything by cosine squared. And that ends up nice. Sine squared divided by cosine squared is tangent squared. Cosine squared divided by cosine squared is 1. And 1 over cosine squared is secant squared. So secant squared is the same as tangent squared plus 1. Didn't have any more solving to do from there. For B, we want cosine squared all by itself. So we're going to, we just have to do a subtraction. If we want cosine squared on this side by itself, we're going to subtract sine squared over. So cosine squared is the same as 1 minus sine squared. Go ahead and use that pause button. Pause and try to figure out what's going on with cotangent squared here, and then come back and see if you can match my answer. Right, hopefully you followed directions. In order, cotangent squared, remember, is cosine squared over sine squared. So we need sine squareds on the bottom in order to get cotangent squared. So I'm going to divide everything by sine squared. Sine squared divided by itself is 1. Cosine squared divided by sine squared, we said, is cotangent squared, which is why we picked sine to divide by. And 1 over sine squared is cosecant squared. The way I memorize this identity when I want to have this guy memorized is that the cos go together, cotangent and cosecant. Only squares, though. And now I can subtract, since I want cotangent squared by itself, I need to subtract this 1 over. So cotangent squared is the same as cosecant squared minus 1. Remember, when we're subtracting, that order matters. When we're adding, it doesn't. So make sure you keep that in mind. Two and 3 are just factoring problems, and these could have been under the equations section as well. We use factoring a ton with trig proofs, though. So again, if you don't like factoring with cosine, substitute in a u. So I'm going to have u equal cosine. And really here, since your middle term is a squared, we can let u equal cosine squared. And that might be a little easier for you to factor with. So I would have 2 minus 5u plus 3. And then if u is cosine squared, cosine to the 4th would be our squared term. And then if you don't like the order, if you don't like having that u squared last, you can switch the order. Just make sure that you carry the positives and negatives with the terms that they go with. 3u squared minus 5u plus 2. Careful when you're factoring with 6 here. 3 times 2 is 6. two numbers that multiply to 6 and add to negative 5, we need two negatives in order to multiply to a positive and add to a negative. So I need negative 3 and negative 2 here. 6 is tricky because 5 and 1 could multiply here as well, but they wouldn't. You can't get a combination. Or I'm sorry, 6 and 1, but you can't get a combination that's going to multiply to positive 6. All right, so 3u squared minus 3u minus 2u plus 2. I'm going to factor out a 3u and a negative 2. And remember, that's going to switch that sign so that your parentheses match, which is lovely. So there's your factored form with your u's. Again, we put those in to make our factoring situation nice and easy. Now we need to substitute back in our cosine squared. So this is 3 cosine squared minus 2 and cosine squared of x, I believe. Yep. Gotta have those variables, minus 1. So that's your final factored form there. I have my negatives in a little bit of a different place on the exam review that I had scanned in. It's an equivalent solution, and it's just because I kept the order from the beginning. So if you have an equivalent solution, that's great. You should be able to find that solution on the multiple choice test pretty easily. All right, number 3 is also a factoring problem, and here, if you want to use some u's, you can. I think I'll maybe do this one on the next video because it's going to take a little bit of time here. All right, see the next video for number 3.